Let me do a tutorial of second order non-homogeneous differential equation. Example. Y double prime plus 4 times y prime plus 4 times y equals to 3x plus 2. Solution. From the typical formula of second order non-homogeneous differential equation, y double prime plus p of x times y prime plus q of x times y equals to g of x. It's a typical form of second order non-homogeneous differential equation. Let me compare the given expression. Look at the left side. The maximum derivative term is second derivative, and therefore it is a second order equation, which equals to 3x plus 2. It is a g of x. So it is a second order non-homogeneous differential equation. Step 1. Write the above function into differential operator form. To do so, let me pick the left side, y double prime plus 4 times y prime plus 4 times y. Just pick the left side. Change it into differential operator, which is d squared plus 4d plus 4 equals to 0. How I change the equation into d squared plus 4d plus 4 equals to 0. Let me repeat it again. Can I write y double prime equals to d square or dx square? And it equals to d square. Y prime equals to d or dx. It equals to d. That's how we put d square plus 4d. Step 2. To find the roots. There are two ways to find the roots. One is simple factorization process and the other is quadratic equation. Look at the equation in step 1, d squared plus 4d plus 4 equals to 0. Is it possible to simply factorize it? Yes, we can factorize it. Just simply do factorization, which equals to d plus 2 times d plus 2 equals to 0. Simplify it further, you will get d sub 1 equals to minus 2 and d sub 2 equals to minus 2. These are the two roots that we got in step 2. Step 3. To find the complementary solution. If you remember the previous topic, second order homogeneous differential equation, for step 3, I have shown you some rules to follow. Let me repeat that rules. Rule number 1. If the root is real and d sub 1 is not equal to d sub 2, then you're going to put this equation. If the root is real and d sub 1 equals to d sub 2, then you're going to put this equation. And in case, if the root is complex root, in this form t sub 1 plus minus I t sub 2, then you're going to pick this equation. These are the exact rules that we applied for second order homogeneous differential equation in previous topic. Now look at here. My d sub 1 equals to minus 2 and d sub 2 is also minus 2. So d sub 1 equals to d sub 2. And therefore I'm going to pick this equation. Y equals to c sub 1 plus c sub 2 times x into e to the d sub 1x. Substitute the value of d sub 1, which is minus 2. And solve it further. This is the final complementary solution. Y sub c equals to c sub 1 plus c sub 2 times x into e to the minus 2x. Now, as we have seen from start till to this, everything is similar as we have done for second order homogeneous differential equation in previous topic. These are exactly similar as they are for second order homogeneous differential equation. But the process onward this is different. We have one extra step, which is step 4, to find the particular solution. Step number 4, to find the particular solution, y sub b. From a typical second order non-homogeneous differential equation, y double prime plus p of x times y prime plus q of x times y equals to g of x. Let me show you the conditions here. Number 1, if the g of x is any linear polynomial degree 1, then I'm going to use this equation. Let's suppose g of x is any linear polynomial degree 1. It means that the power of the variable is 1, like x, 2x, x over 2. Pick this characteristic equation, y sub b equals to ax plus b. This is the characteristic. This is called characteristic equation. Condition number 2. If g of x is any quadratic polynomial degree 2, then I'm going to use this equation. Let's suppose g of x at the right side. You have to look to the right side of the equation, then you decide the appropriate characteristic equation. G of x is degree 2 here. The power of the variable is 2, like x squared, 3x squared, Then I'm going to use this equation y sub b equals to ax squared plus bx plus c. Condition number 3. If g of x is any cubic polynomial, I mean degree 3, then I'm going to use this equation. Let's suppose g of x is any cubic polynomial. I mean the power of the variable is 3. Like 4 cube, x cube. Then I will pick this equation y sub b equals to x cubed plus bx squared plus cx plus e. Condition number 4. If g of x is any constant value, then you need this equation y sub b equals to a. Let's suppose g of x is any constant like 1, 5. Then I will use y sub b equals to a. Condition number 5. If g of x is any exponential function e to the x, then you need this equation. Let's suppose g of x is any exponential function like e to the x or 2 times e to the x square or e to the x square. Then I will need this equation y sub b equals to a times e to the x to be used. Condition number 6. If g of x is any trigonometric function, then use this equation. Suppose that g of x is any trigonometric function like sin ax, cos ax. Then you're going to use this expression y sub b equals to a cos ax plus b sin ax. Always look to the right side, g of x. And the next thing is that if the equation is second order, then differentiate y sub b, which is a characteristic equation, 2 times. Y sub b is the characteristics equation. These all are the characteristics equations. If the given expression is second order, then you're going to differentiate the relevant characteristic equation 2 times. If the equation is third order, then you need to differentiate it 3 times. Suppose that g of x is x squared. It's a quadratic polynomial. It is degree 2. I will pick this equation y sub b equals to x squared plus bx plus c. This is the very first thing in step 4 to check. The next thing is to look to the left side of the given expression. If the equation is second order, then you need to differentiate the characteristic equation y sub b 2 times. If it is third order, then you need to differentiate it 3 times. Since the maximum derivative term in the given expression is second derivative term, it is a second order equation. Therefore, I'm going to differentiate y sub p 2 times. So let's differentiate y sub p. Y sub p prime equals to 2ax plus b. Differentiate y prime now, which is y sub p double prime equals to 2a. And I'm going to stop it here because the maximum derivative term is y double prime. Now substitute the values of the characteristic equation for the left side. For y double prime, put the value of 2a. Just replace y double prime by 2a. And for y prime, put the value 2ax plus b. Just replace y prime by this value. And for y, substitute the value ax squared plus bx plus c. Now, in case if the given equation is a third order non-homogeneous differential equation, then I'm going to differentiate the characteristic equation y sub p 3 times. Let's suppose the given expression equals to x to the 3. The very first thing in step 4 to check for the right side, which is g of x. If you see the g of x is x to the 3, it is a cubic polynomial because it has degree 3. And therefore I'm going to pick this equation y sub p equals to ax cubed plus bx squared plus cx plus e. This is the first thing. The next step is to check the right side of the given expression. Look at here. The maximum derivative term is third derivative term. So it is a third order non-homogeneous differential equation. Therefore, I need the characteristic equation to be differentiated 3 times. Differentiate y sub p to have y sub p prime equals to 3ax squared plus 2bx plus c. Now differentiate y sub p prime to have y sub p double prime equals to 6ax plus 2b. Differentiate y sub p double prime, which equals to y sub p triple prime equals to 6a. And I need to stop it here because the maximum derivative term is the third derivative term. Substitute 6a for the y double prime and 6ax plus b for the y double prime. 3ax squared plus 2bx plus c for y prime. and ax cubed plus bx squared plus cx plus e for y. Let's go back to our own equation, which was y double prime plus 4 times y prime plus 4y equals to 3x plus 2. Compare it with the second order non-homogeneous differential equation. These are second order derivative terms, and p of x is 4, q of x is also 4, g of x is 3x plus 2. The rule says that if the given equation is second order, then differentiate the characteristic equation y sub p 2 times. But the very first thing in step 4 to do is to check the right side of the equation, which is 3x plus 2. It's a linear polynomial function with degree 1 power. So therefore I will pick this equation y sub p equals to ax plus b. Now I will check the left side of the equation. And the maximum derivative term here is second derivative term. And therefore I need to differentiate the characteristic equation y sub p equals to ax plus b 2 times. Differentiate y sub p to have y sub p prime equals to a. And now differentiate y sub p prime to have y sub p double prime equals to 0. Now substitute these values in the left side. For y double prime I put 0, and for y prime I put a. For y I put ax plus b. Simplify the equation to have 4ax plus 4a plus 4b equals to 3x plus 2. Now I need the value of a and b. To find the value of a and b, I'm gonna compare the left side with the right side. At both sides we have x variable with degree 1 power. Therefore the constant 4a equals to 3, which implies that a equals to 3 over 4. This is the value of a. Now to find the value of b, check it here. 4a plus 4b. This is pure constant term. And check it with the pure constant term at the right side. At the right side we have 2. So 4a plus 4b equals to 2. Substitute the value of a here to have b equals to minus 1 over 4. That's how I got the value of a and b. Therefore particular solution y sub p equals to ax plus b. Y sub p equals to ax plus b is the characteristic equation that has been taken. Now substitute the value of a and b. The value of a was 3 over 4 and the value of b was minus 1 over 4. This is the final answer of the particular solution, which is 3 over 4x minus 1 over 4. Step 5. To find the general solution. For the general solution, add y sub c and y sub p. Y sub c is the complementary solution. If you remember, that is the answer that we got in step 3. And y sub p is obviously 3 over 4x minus 1 over 4. Just add y sub c and y sub p. Y sub c was c sub 1 plus c sub 2 times x into e to the minus 2x. This is the answer in step 3. Put the exact answer here. 3 over 4 times x minus 1 over 4 is the value of y sub p. So here is the final answer for the equation. And that's all.